Welcome back to the final part of this lecture. We're looking at the ROM, RAM and storage together with the motherboard and the power supply unit. So once you understand about the CPU, which means how the computer compute, then we look at how these other parts of the computer works, right? So we have the ROM. ROM is basically the full name of this one by itself is read only memory, or read only memory. The word itself, read only, it means can only read. You cannot do anything, you cannot modify. It means it's fixed. Alright, inside a computer there will be a ROM. ROM usually it will be attached with the motherboard. You attach the motherboard, and then before you can even start a computer, when you boot up the computer, electric circuit go into your computer through the power supply. It will start with this one, the ROM, right? The electric will go here. The electric will go into the motherboard, and then it will go to the ROM. The ROM will start by executing the basic process. Not really execute, right? It's like a boot, right? It will boot up the whole system. So basically, number one it will do is it will boot the system. They call it bootstrapping the system, right? Bootstrapping the system. It powers up the CPU. The CPU looks at the RAM, the ROM for instruction to begin the booting process, right? The booting process. Once it boot up, it will read, right? It will read whether what type of OS before it load to the OS, right? So usually the features of this one, right, the ROM, is non-volatile storage. Alright, opposed to this one, which is volatile. Volatile here means change, alright. Non-volatile means it doesn't change, right? It doesn't change. It has a fixed firmware attached to it. It means later when you look at the chapter after the following chapter, we talk about the OS, how the computer boot up the OS. We will look at the ROM, how it goes through the BIOS process, alright. And the ROM actually has this BIOS inside, or stored inside the ROM, so that it will have a low-level instruction to start up the computer. Of course, the ROM also functions to identify, alright. It identify the hardware. So the other components, for example, the input or the output, the keyboard and blah blah blah, right? Keyboard and the monitor, hard drive. So the question here is it important to have a ROM? Of course it's important because it will be the startup and function. Without it, the system would not know how to initiate the hardware. Alright, basically it's like fixed instructions. Now we go to the RAM. So after the boot up process, go into the system, run the system, the OS, start up the computer, go log inside, then the RAM will serve as the primary part before it actually it will do all the instruction processing over there. Full name of this one is random just random access memory. Alright, so over here by definitions, right, by definition is it serves as the primary system memory, temporarily store data and instruction that the CPU needs to access quickly during the operation of program. So usually if you have a higher RAM, it means your computer faster. Alright, because you can actually over here it can enable a faster multitasking. Alright, basically it allows more flow of instruction to the CPU. However, the CPU must also be fast. It both have to be fast to actually have a faster computing speed, right? They call this computing speed. Alright, it will somehow affect the computing speed. So opposed to this, the random access memory is a volatile memory. Means it can change, and when power is off, oh yeah, one more thing is that when power off, right, this thing is gone, but this thing still stays, right? What is inside the instruction? Alright, instructions inside this one already gone, but inside the ROM still stays. Then we talk about the RAM. Evolution. RAM evolution, we can see, alright, when you want to buy the RAM to put inside your computer, there's different version, alright. DDR, or they call it the DDR over here, double data rate memory. Actually there's before that, there's another, and there's a different generation for DDR. I forgot what's that. Alright, but before that there's another generation, but after that we have this one, double data rate. If I'm not mistaken, right, it takes the loop like this, right? If you see the electricity, the AC and DC, double data rate take holds of both when there is input and there's no input when there's no current. If I'm not mistaken, I forgot. Forget about this. Just confuse you only. Just think that DRR is double data rate memory. All right. It is faster overall. All right. We're not going to go into this hardcore, but just to let you know that now we have DDR1, 2, 3, 4, and the latest is the 5th. So if you find yourself checking out computer and if you check up the RAM, you might want to just pick the 5th one because the 5th one is the fastest. There's some detail notes you can look inside. I'm not gonna talk about much. Very simple. Long story short, the latest means faster. Alright, same like any other things, right? The latest tech means the faster. Alright, it means you can process better. It is way superior than the previous one. Then we got the final one over here, which is the storage. Storage over here is memory that holds the data for a long term. Alright, you got the HDD hard disk drive and the SSD solid state drive, and there's this one NVMe, which is the non-volatile memory express SSD. Very simple in the storage logic over here. The more latest one means the more faster. Same thing goes with that one, and then more safer. This one, the disk. This one use disk, you know. There's a disk inside inside the hardware. Over here doesn't have a disk. It's straight away inside the hardware is a chip. And this one actually, rather than the older, let me see. It also has a chip, but basically it moves faster. Of course, these are storage. When you talk about this thing, it just store data for long term. I store data for long term. And finally, we move to the motherboard. Of course, inside a computer, there's this motherboard. It's a chip. Let me see what's the definition over here. Motherboard is a central printed circuit board, alright, PCB, alright, in a computer. It serves as the main connection point of all core components like the CPU, memory storage, peripherals, and other devices. So they got a central hub to all the devices. We can say that the motherboard is the keyword over here is the central. Central to all the core components slash connection points. Okay. Whereas the power supply over here, power supply unit is responsible for supplying the computer with electric power. Electric power. All right. Got supply, right? It supply electric power to the computer slash the component inside the computer. Then there's one more thing over here, which is the cooling and thermal management, MENT, management. Basically, there's the fan, right? The fan. All right. There's the heatsink, all right? So you got this motherboard. So over here, maybe you got the CPU. Then there's this heatsink that will be on top of this one. Alright, just to cool off this CPU, because electric, right? You got the PSU over here, which is the electric. Electric equals to heat. When heat is too much, is equals to burn. When burn equals to spoil. So you got your chip fire. Alright, then it's spoiled. So what you want to do is you want to cool this heat away when you when whatever things that you do, right, it will send in more current or electric. Then when you do higher processor, means a higher current, means it process faster, then it will be more hot. Then that's why you need a heatsink to prevent the CPU from burn away. There's different components and so on, right? That's it. So conclusion, right? Conclusion over here. Conclusion. Number one is what is inside a computer. All right, we got very simple. We got CPU. We got this one right here. Got CPU. we got the motherboard, we got the ROM, we got the RAM, we got the storage, right? We got the motherboard. Did I say motherboard? We got the power supply unit. To how computer compute. So first, they count by binary system, we count by decimal system. Second thing is they use complex logic gates to perform arithmetics calculations like what I showed you just now. And how they do it, they use the CPU actually has it has different parts, but one of it is the ALU, algorithmic, let me see, algorithmic logic unit. All right, we got the CU, the controlling unit, to do the instruction cycle. What is instruction cycle? We got the fetch, we got the decode, execute, and store. All right, first you fetch from elsewhere, basically the RAM or some parts of this the register or something. Then it decodes, the CPU decodes it, then it will execute whatever process that is instructed to, and then it will store the process. We talk about what is ROM, RAM, and then the storage. Basically, this one is fixed. The memory inside here is fixed. This one is changeable. Without electricity, it dies off. This one, without electricity, it stays. Right? This is just a random access memory. Right? It's just this memory doesn't stay when electric. Let me just say over here. This one fixed, and with no electricity it's still fixed, it doesn't change. This one it changed, but with no electricity it is gone. This one it stays, with no electricity it still stays. Right? And finally, number 5, we talk about the motherboard. Motherboard plus the power supply unit plus the thermal, right? The thermal, the cooling and thermal management. All right, this one is the central to everything. Basically, it stick everything together. Stick all of this together. This one power supply to this one, of course, it also stick this one together. All right, then you want this to cool down this one. What you should take prep from here is very simple. I would sum up with a statement over here is that mostly, right? Mostly latest, right? Later technology equals to faster processing. Okay, how it link to the accounting? Basically, this is the computer I don't know, this is the hardware. Alright, the CPU. Now we learn about the CPU. Basically this one, the engine, right? The engine. I don't know what to say. Yeah, you're learning something over here. Alright, this accounting part will come later, after when we learn about the keyboard, the input and the output, which is the next next session. And then we learn how the OS power up this one, link between this, everything combined all together to come up with going to the software. Then only we'll come back to the accounting part. These are all the hardware, right? That's it. See you all next week on more on this input and output of this system. Alright, we'll go through also a very basic idea.